Problem number 1319. Number of operations to make network connected. There are n computers numbered from 0 to n-1, connected by Ethernet cables connections, forming a network where connections I equals AB represents a connection between computers AI and BI. Any computer can reach any other computer directly or indirectly through the network. You are given an initial computer network connections. You can extract certain cables between two directly connected computers. And place them between any pair of disconnected computers to make them directly connected. Return the minimum number of times you need to do this in order to make all the computers connected. If it is not possible, return -1. Okay, so first of all, will there be like A and B? Can it be the same for A and B? Okay, not the same. And the range of A, B will be in 0 and n, yes. Okay, and does this have a direction like A must be, like A to B? No. Okay. Okay, there are no repeated connections. Oh, that means, yeah, no two computers are connected by more than one cable. Okay. So I think basically the problem wants us to find the isolated computers. And for okay, so for if 3 computers are isolated, we need at least three adjustments, three operations to make the computers reach each other. Well, but then we cannot, we should not, we also cannot lose our own connections. Okay, so example 3, there are 6 nodes, 6 computers, but there are only 0, 1, 0, 2, 0, 3, and 1, 2. Okay, so basically 0, 1, 0, 2, 0, 3, 1, 2. They don't have 1, 3. So I think for at least six computers to connect. Oh, this only needs 5. Yeah, so for 6 computers to connect, we need at least 5 edges, 5 cables. And yeah, since this only has 4 cables and we have 2 left, 2 isolated nodes, then how many nodes? Yeah, we have 2 isolated nodes, then it's not enough. Okay, and this is 3. Okay, so we need to find out how many isolated nodes are there. And I am not sure, if we have 2 groups, then maybe we have 10 nodes like this, and so for 10 nodes we need at least 9 cables, and now currently we have 3, 5, 8. Okay, so it's not enough. Is that correct? But we did not. Okay, so maybe let's find out how many isolated we have I have 4 nodes and 3 edges, 3 connections will be enough. I think we can first return if length connection is smaller than n-1, then you can return -1. And else we would try to count how many operations we need. I'm thinking of do we need to build an adjacency list? Yeah, if we build, then not sure if it's helpful. Okay, so for example 1, it will be 0, 1, 2, and 0, 2. 2 will be 0, 1. And since we have 4 nodes, 3 will be empty. Okay, so we can find the one that is empty. Yes. Okay, so let's first find empty node. The isolated node. So we will start to build adjacency list for connection in connections. A, B is C, and let's have nodes equals, we will have default date this I think I will have the length of, I will have default date. And so nodes A append B, and nodes B append A. Okay, so we now know who is isolated. Okay, so now we need to know we have the length of connections. That means how many, like, cables. We can have cables. Okay, we have cables, and now we know how many computers are lost. So that's disconnected count equals 0. So for node in nodes, I forgot. Maybe it's key value, KV. So if v equals, so if v is empty, then this counts plus 1, and then we can return disconnected count. So Python loop dictionary. Oh, can you use values? Okay, let's print the notes. And that's print v. Oh, okay, I think I should use like use range n for I in range n, and if nodes I is empty, then dictionary disconnected count should add 1. Okay, it's wrong. What did I miss? Okay, so this is correct. When a computer count is n, we need at least n-1 cables. Yeah, so this is correct. I think the solution has explained really well that, and it kind of, I think I'm in the right direction, but did not figure it out. It says like, if there are k groups if there are k groups, then we need at least k-1 we need at least k-1 operations to make all the k groups into one group. And so and also if a group its node has m, its node count is m, then if its edge is connected cable has more than m minus 1, then there must have extra cables, and for that extra cables we can use it to connect the group K groups. So it says we can use a recursion or iteration that every time find an extra cable and connect it to the two groups, and then the next problem will become find an extra. Since we connect two groups, then maybe there is extra there will be extra cables, and we can use it to connect other groups, and then so kind of gradually merge the groups together into one group. Okay, so we need to find the groups in the current situation, and so if we have K groups now, I think it would be like K groups, we need at least K minus 1 operation to merge groups together. I'll say okay, at least K minus 1 cables, and so we need to find and for each group the count if we have m nodes, if we have n computers, then cables larger than m minus 1 will be extra. That means it can be used to merge groups. Okay, then I think we should the first thing that we need to do is find the K groups. And yeah, for this, to find the K groups, how many groups are there? Given the input, then we should have visited. That will be false multiplied by n nodes. Okay, then let's first remove this. So yeah, we'll have 4. Yeah, for nodes in I'll say for computer, oh, it's nodes. So let's have for node in nodes. I think we'll use n for I in since in range n, and yeah, if we use node, then this 3 will not be checked. So it will not be checked. So we will use n, and if visited, if not visited, then let's start our finding groups. So we'll have group count equals 0. And count. Okay, so after DFS, we will have group count plus 1. I'm thinking of okay, so now DFS. DFSI, we will find all the connected node in given node I. So if so for nodes in nodes I, let's find, and we should first check if it's visited or not. If not visited, then let's go find it's connected node. And we should put it to visited. Okay, and now we have k counts, k groups, then it says the k groups minus 1 will be its answer. Oh, cool. Why? So like return group count minus 1. So it's like a greedy approach.